into the room dripping in gold. Yeah, dripping in gold. I walked into the room dripping.
So they give us the following problem. E to the 3x cosine of 4x dx. Okay, so from 8.1, this is the integration by parts. So this is going to be our u, and this will be our v. Okay, so u on the side here is going to equal e to the 3x, du equals, and we chose dv to be the rest. This is dv. dv is cosine 4x dx, and v is over here. So du is going to equal 3e to the 3x times dx, and v is 1 to the 4th, sorry. So let me go back. 1 over 4 sine 4x. Okay, so that'll get us back to the cosine 4x when we differentiate once. Alright, so plugging it into the formula, we're going to get e to the 3x times 1 over 4 sine 4x, okay? And then minus v du. So v is going to be 1/4 sine 4x. du is 3e to the 3x dx, right? Okay, and then this simplifies into, well, we can bring the 3/4 out. So I'm just going to write 1 over 4 e to the 3x sine 4x minus 3 over 4, that's a 3, sine 4x times e to the 3x dx. Okay, so this, again, this is another integration by parts here. So we're going to do the exact same process for this one, okay? So we're going to pick u to be the same, e to the 3x, and then dv is going to be the rest, so that's our sine 4x dx. Okay, so du equals 3e to the 3x dx, and v would have to equal a negative 1 over 4 cosine 4x. Okay? Alright, so then once we do this, okay, this is going to get kind of long, but that's a 1 over 4 e to the 3x sine 4x minus 3 over 4. And then in brackets, we're going to implement the integration by parts rule. So u times v is going to be a negative 1 over 4. And I guess I'll just write, yeah, e to the 3x cosine 4x. So that's u times v minus integral of v du. So v, in this case, in this second integration by parts, is v times du, which is 3e to the 3x dx, right? Okay, and then close brackets. Alright, so then also there's a plus c in here, but I'll write that a little bit later. So what we actually have here, so keep this in mind, all of this bottom row, because I'm going to equate this to the very first thing that they gave us, okay? So I'll rewrite it on the new page. We're going to have an e to the 3x cosine 4x dx. So this is the problem that they gave us, and this actually equals the following. We're going to have, this is what we've gotten so far. I'm just going to copy it down. So we have e sine 4x, and then we have a plus 3 over 16 e to the 3x times cosine 4x minus, and this is the very important part, 9 over 16 integral of e to the 3x cosine 4x dx. And then there's a plus c over here too, just because it's an indefinite integral, and we integrated a couple things so far. Okay, so see how here on the left, that is the exact same thing as what we see in this term, right? Aside from the coefficients. So technically we can think of this as like a quantity in itself. So this is kind of like, let's say, I don't know, this is star variable. star. So these are basically, the point is that these are like terms. So what we can do is add 9 over 16 of this integral to both sides, okay? To both sides. And then once we do this, we get 1 plus 9 over 16. So that'll be 25 over 16 of this integral on the left. And then cosine 4x dx. And then, so that goes away on this side, right? Because we did the opposite function, opposite operation. Plus 3 over 16, and we just copy the rest down. Okay, cosine 4x, and then our plus c. Okay, so then from here, it's pretty simple what you do just to get the integral by itself. We're going to multiply times the reciprocal of the fraction. So that'll be 16 over 25, and we'll do that on both sides. So times 16 over 25, and we get our final answer. So integral of e to the 3x cosine 4x dx is actually going to equal, and I write the fraction in front, so 16 over 25 of all of this. So then we have 1 over 4 e to the 3x, that's a 3, sine of 4x plus 3 over 16 e to the 3x cosine 4x, and then the plus c can go inside or outside. It's just a constant either way, so I'll just put it outside. And then we have our plus c. Okay, so you see on that one we had to apply the integration by parts rule twice. So sometimes you'll need that. Instead of just doing it once and getting your answer, you'll have to do that, and then think of the like terms on both sides. Okay?